Good morning, good day, everyone. I believe that you're all now entering into the chat room. So I just wanted to thank you all for welcome to the CIFST Food Cluster meeting. And this is a very historic right now. And thank you for being part of our inaugural CIFST Food Cluster event here. So as you are filling the meeting space, I will just share with you a little bit on the agenda for today. For those of you who don't know me, my name is Phillip Leewing, and here is the agenda for today. So basically, we have 60 minutes here. It's going to be very tight. We have some opening remarks from Dr. Tony Savard here, and Dr. Savard is the Director of Research and Development and Technology Transfer with Agriculture Agri-Food Canada. And then a little bit about the food cluster, as well as the management committee by myself, as well as we'll have a third speaker, which is Dr. Dan Ramdath, who is the Associate Director of Research and Development and Technology Transfer, again from AFC. And he will be sharing us a little bit in terms of the role of AFC scientists with respect to the food cluster. After the short message by Dr. Ramdath, basically we will introduce you to the activities. There are 9 activities, or these are the proposals or the projects, ranging from novel feedstock for plant-based analogs of fermented dairy products by Dr. Michael Gansel. You'll notice that we start at number 3. Number 1 and number 2 activities are basically administrative activities. Number 4 activity is basically AI-based tools for turning food waste into energy and fertilizer by Dr. Bolomar. Number 5, value-added hemp seed by Dr. Rong Chow. Number 6, advanced technologies for sustainable upcycling of barley brewers spent grain by Dr. Lamia Hossein. And number 7 is fermentation of pea protein, plant-based milk by Dr. Raj Verma. Number 8, reducing HGH by improving organic waste management by Dr. Alexandra Gorchek. Number 9, plant-based phenolic complexation towards healthy plant-based food development, Dr. Lingyan Chen. Then we see Dr. Michael Gansel again with novel sanitation technologies for improving food quality and safety. And finally, we'll finish the meeting today with Dr. Raj Verma talking about fermentation of mushroom waste to produce umami extract. Now, I do not want to take up too much time, so I will then pass it on to Dr. Tony Savard, who will give us some introductory remarks. Okay, so we'll pass it on to Tony, please.
Thank you, Philip. Hi, everyone. So, as Philip mentioned, I'm the Director of Development and Technology Research for Sherbrooke, Quebec and Normandin Research Center. I'm also leading the national portfolio agri-food for AFC. And finally, I'm the AFC chair of this cluster. So it's my pleasure to welcome you to the Food Sustainability and Resilience Cluster virtual meet and greet. This meeting offers an overview of the 9 scientific activities in this cluster, and each activity will be presented by its principal investigator. The Canadian agri-food landscape is changing quickly and facing multiple challenges, as you are all aware, associated with sector growth, increasing costs, labor shortage, and certainly changing market demand. The need to produce more sustainability is pressing, and we recognize that research is critical in closing knowledge gaps emerging from this change. While many researchers in the federal government are working together productively to address these gaps, our academic and industry partners are also key collaborators in our continued effort to advance science. The Sustainable Canadian Agriculture Partnership provides strong support for science, research, and innovation to address challenges, seize new opportunities, open new markets, and strengthen the resiliency of the sector. The AFC Agri-Science Program cluster, which is this cluster part of it, aims to support collaboration in three key priority areas that will promote energy reduction and efficiency, innovative production technology, and practices. It supports projects that mobilize industry, government, and academia through partnerships and address national priorities as well as horizontal issues by accelerating innovation and providing support for pre-commercial activities that benefit the agri-food sector and Canadians in general. These activities, supported by this cluster, contribute to the SCAP research priority of climate change and environment, economic development, and sector resilience and societal challenges. These activities will hopefully inspire new ideas and novel approaches to address outstanding research needs. In closing, I would like to thank Madam Karen Ozer and Dr. Phillip Lee Wing from CIFST for organizing this meet and greet, and providing a platform for our scientists to share their work. I also want to mention the Food Science Cluster Knowledge Transfer, which will take place in October 1st in Mississauga, Ontario. I hope that you will all be able to join us there. I'm passing the floor now to Dan Ramdad. Dr. Ramdad, please.
Oh, I'll take it back first before I pass it on to, yes.
Sorry,
okay.
Phillip. Go ahead.
Sorry, Tony. Okay, thank you, Tony Savard, for the introductory words. And hello and good day to all. Basically, this meet and greet is to introduce to all members, stakeholders, industry partners, academia, and government partners that we are pleased to announce that AFC, which is Agriculture and Agri-Food Canada, and CIFST, which is the Canadian Institute of Food Science and Technology, have signed a collaborative research and development agreement under the Agri-Science program. This program places emphasis on industry-led research and development stream for the formation of an agri-science cluster. The cluster, a little background on the cluster right now. The cluster was assembled in early 2023. Next slide, please. Yes, the task team was put together to explore the feasibility of the formation of the cluster. The team comprised of the sitting president. At that time, it was Louis Ayotte, past president, which is myself, Phillip Lee Wing, an AAFC representative, which was Dr. Steve Cree, and CFST management, which is Heidi Looney and Constance Wrigley Thomas, under the advisory and support of Dr. Tony Savard and Dr. Dan Ramdad. As you can see, this required tremendous amount of speed, commitment, dedication to make this happen. Through the call for proposal, 20 research proposals were received. Next slide, please. Each were peer-reviewed by the Scientific Advisory Board chaired by Dr. Steve Cree. 12 proposals were recommended to AFC, where 9 proposals were finally accepted. Now, currently, next slide, please. Currently, our food cluster is managed by Constance Wrigley Thomas, who is the cluster manager, myself, Phillip Lee Wing, who is the food cluster science director, Karen Hauser, who is the food cluster director, and of course, guided by Scientific Advisory Board, external to CFST. Next slide, please. Today's meeting is simply a snippet of an in-person cluster event, which is scheduled for October the 1st later on this year. By attending this event, you will get to know a bit more about the cluster, the process, the projects, and how you and your company can submit a proposal for funding in collaboration with researchers in the next cycle. So today we will get a brief introduction to the 9 activities and the researchers behind the projects. At this point, I would like to pass this over to Dr. Dan Ramdad from AFC, who will share a bit more on AFC's researchers' role with the CIFST food cluster. Dan.
Thanks very much, Phillip. It's a pleasure to be able to talk to this group today. It's really delightful to see this happening and the launch of the cluster, because this has been a huge amount of effort, and I could congratulate CIFST for taking on this responsibility to lead the the cluster application to form the cluster. As you, both you and Dr. Savad mentioned, forming a cluster and the associated activities that are required to have a successful cluster are quite cumbersome. They are laborious. They require collation of ideas, bringing partners together. It absolutely requires industry funding, because the way the SCAP, the Sustainable Agriculture Partnership, works is there is a matching contribution between industry and the government, AFC. So it also involves, as was mentioned, it also involves the scientific integrity, assessment of the scientific integrity of the proposals, followed by external reviews, and then close interaction with AFC. So the AFC programs branch oversees the coordination of the cluster activities and provides a lot of guidance on how to ensure that everything is streamlined, that the projects that are submitted for funding align with the strategic direction of the government. So that's really important. So this is a bit different from, say, funding at university. The research we do at AFC is mandate driven. It's driven by the strategic direction of the government of Canada, in particular, the Minister of Agriculture and Agri-Food. So we conduct mandated research. And so moving forward, you'll see of the 9 activities that were approved, I think 5 or 6 of them involve AAFC scientists. They are either collaborators or they are leaders. They lead the activity under the cluster. And that's not by chance. The AAFC scientists are specialists in their fields, and they do mandated research. Their job is to do work that benefits the public, which is different from work conducted in academia. So moving forward, I would encourage the industry partners who we really value, and we want to, our job is to support the industry to ensure it's economically viable. So we need to reach out to each other. And so the event on October 1st is another step in us getting to know each other. So we need to get to know each other, but also to know that we, the AFC, the Science and Technology branch, has a wide range of scientific expertise that's waiting to support industry to succeed. So please reach out to us today, reach out to any of the scientists today or on October 1st. We certainly look forward to meeting you, the stakeholders, our stakeholders in industry, to help you to succeed, to meet your scientific needs. Thank you very much.
Thank you, Dan. I appreciate that. Can you put the agenda back on to the screen again, please? So with respect to the agenda, at this point in time, I would like to call upon the principal investigators for each activities to say a few words about the project. Tell us a little bit, not too much in detail, just tease us a little bit in terms of what the project is all about. Who are you collaborating with? And let's start with Dr. Michael Gansel, who will speak on the novel feedback for plant-based analogs of fermented dairy products. Michael, are you there?
I'm here, yes.
Very good.
I got myself unmuted. I want to briefly introduce the problem. We aim to increase the proportion of plant protein in the Canadian diet for the simple reason that plant protein is produced much more sustainably with a lower water use, with a lower carbon dioxide footprint than animal protein. And if you take plant-based analogs of cheeses, for example, we have 2 possibilities to do this. We can formulate products, which means we use purified protein, starches, other ingredients to get something that hopefully works like cheese in a Canadian diet and finds consumer acceptance. Or we can do what we have done in cheese production for a couple of thousand years. We can use simple ingredients, which means unmodified plant seeds and possibly a small proportion of protein isolates, and start fermenting to get the desirable sensory properties, texture, shelf life, and so on. The problem is that first, we have to find the appropriate protein source. Second, we have to find the appropriate fermentation organisms. We started with a fermentation 2 years ago in collaboration with an industry partner. If you look at cheese fermentations, you have a primary acidification culture. You have a adjunct culture, which is active and takes over during cheese ripening, which can be weeks or months. In many cases, we have a surface microorganisms, yeasts, fungi, or other, which is mainly responsible for flavor formation and for proteolytic activity. And we started screening our strain collection. We have close to 1,000 strains of lactic acid bacteria in our collection. We started screening which are the best acidification cultures, which are the best adjunct cultures, and which organisms can we use to improve quality by proteolysis, degradation of polysaccharides, degradation of phytochemicals. And in a couple of cases, the surprises were very small. We found Lactococcus lactis and Lactoplantibacillus plantarum to be the best acidification cultures. In other cases, we found a few more surprising relationships. One is bacilli, make very good cultures in production of plant-based cheeses. They contribute through proteolysis. And second, the adjunct cultures that are suitable for plant-based cheese analogs are very different from the ones that are used in cheese making. And we will extend the work to yeasts and possibly fungi. On the protein feedstock, here is where my co-investigator, Jiangping Wu, comes in, an expert in proteins and bioactive peptides. He will extract canola protein, which is currently an underutilized protein source that is mainly going into animal feed. Extract canola protein to see whether it can replace other protein concentrates in our complex plant-based recipes for plant-based cheeses. And so I hope in 2 or 3 years from now, we will have solutions for the selection of starter cultures, and that will be a bacterial community, not a single strain, and B, an alternative for pulse proteins or soy protein that is based on extraction from waste streams and not from dedicated purification for production. So that's the brief summary. I think I should stop here. You're muted, Philip. You're muted.
I'm muted. I'm back on. Okay, very good. Thank you again, Michael. And I was just about to stop you and tell you that save some of that good stuff for October the 1st. We don't want to give away everything right now. So the next person on the list here is Dr. Bolo Mar, who is going to talk a little bit about his project. Bolo, are you there?
Yeah, I'm here.
Okay, go ahead, please.
Hello, everyone. Good afternoon. And first, I'd like to acknowledge your management and get us to go through this important food cluster. And although some of them have not met by person, like Dr. Tony Savard. I don't know. I visited Sherbrooke Center 7 or 8 years ago, but I don't know we met in person. And Dan Ramdes, and also that's in Guelph, and I don't think I met him. Fortunately, I met Dr. Phillip Wen last year, and we talked with Steve Cui and over the phone many times. And of course, we have to acknowledge the sponsors of the project industry for the circle science and CIFST and the leadership for this become reality. There's a lot of struggle over the past couple of years, but finally we get funded. As the title indicated, what we wanted to develop is an AI-based tool for turning food waste into energy and biofertilizers. The background, as we know, Canada, we generate a lot of food waste, 2.3 metric million tons every year. This creates a lot of problem because our landfilling takes a lot of room, and if to the incineration and cause serious environmental problems. On the other hand, the food waste is important nutrients for plant growth and suitable for the agro ecosystem. As Director Tony Savard mentioned, the government has the mandate for the environmental. That's a very important one. We wanted to reduce greenhouse gases, and we wanted to push the promote the productivity. We're using a circular economy. I think our project will address all of these aspects. Specifically, we wanted to develop an AI-based food sorting and digestion platform to provide Canadian agricultural stakeholders with guidance on the use of biofertilizers as an alternative or supplement to synthetic chemical fertilizers. And this involves two steps. First, we will do a lot of in-house laboratory experiments. I have very fortunate with Dr. Guoqi Wen, and I discussed with Dr. Phillip, and is a very talented person. He has a computer background and also environmental and soil science training in PhDs. So the first two objectives, developing an image sensor-based food waste sorting platform and a fully scaled food processing prototype will be doing in-house. And for the fermentation, optimize parameters and to effectively recover energy and nutrients for all types of sorted food waste. So we work really hard since we get approval of the project in December 2023. And we hope we will get enough fertilizers by the time of next growing season. So that means in May 2025 for the third objective to evaluate the effectiveness of this biofertilizer and the field conditions of Canada. And our team, some of them is already, I believe they are in the meeting, and that they're including research scientists from Ontario at the Hero Station, Dr. Tiequan Zhang, and several research scientists from Quebec Research and Development Center, Norzadi, Dr. Ancina Camborist, and Jean Lafont, and from the prairies, like Silver Current RDC, Dr. Mervyn St. Louis, and Lethbridge, Dr. Sandra Yanni. I hope in October I will show you more detail of our project. Thank you very much.
Fantastic, Dr. Mar, appreciate it. And next on the agenda is Dr. Ron Chow, who is going to talk a little bit about value-added hemp seed and processing fraction for improved human health. Okay.
Fortunately, Dr. Ron Chow was unavailable this morning, so I will be speaking in his place. So I am actually the co-PI on the project. I have expertise in immunology and characterizing impacts of dietary components on intestinal health. And Dr. Ron Chow has expertise in food bioactives, chemistry, and biochemistry. And our other team member, Dr. Matthew Noseworthy, also at Agriculture University of Canada, has expertise in protein quality assessment and amino acid biochemistry. And our collaborating team member, Dr. Mehmet Tolbeck, who is the president of the Saskatchewan Food Industry Development Center, Inc., has expertise in ingredient processing and food product development. And our industrial collaborator is the Canadian Hemp Trade Alliance. In our project investigating the value-added properties of hemp seed and its processing fractions, our plan includes 4 major objectives, including the assessment of the agronomic and baseline nutritional qualities of semi-processed hemp cultivars that are currently grown in Canada. We plan to assess nutritional baseline content for minor and major bioactives of the different genetic sources of hemp, and then we plan to proceed with the exceptional cultivars containing a desirable protein content, basic nutrition, and amino acid profiles. Our second objective is to characterize and identify nutritional and bioactive compounds, including phytochemicals, proteins, peptides, and fiber, and whole seeds or processing fractions such as the oils, the fatted meals, or hulls. Our third objective is to evaluate the nutritional quality, bioaccessibility, and bioavailability of hemp protein and related nutritional and health attributes of the bioactive compounds in processed hemp and on bioactive markers related to chronic inflammation using cell culture and animal models. And our final objective is to determine the impact of processing, including fractionation, fermentation, and thermal processing on hemp nutritional attributes, and also to develop hemp seed-based food formulations potential for baked goods. I apologize for my background noise. I have a cranky toddler and unfortunately no support this morning. By the project completion, we aim to deliver fundamental baseline information on the nutritional value of hemp seed and its various processing fractions in both semi-processed and final processed forms. And additionally, we aim to identify possible health-related benefits of hemp seed and to prototype food formulations from several fractions of hemp seed processing. So that's it for me, and I look forward to meeting everyone.
Sandra, you're a star. I can tell by the distraction in the back there, you have persistence. You just stay on course and you finish up what you had to do. Very good. Thank you very much. So I believe your project's going to be fantastic in terms of staying on course. The next person on the list is Dr. Lamia Hussein, who's going to talk a little bit about advanced technologies for sustainable upcycling of barley brewers' spent grain.
Yes, hello everyone. I actually prepared a small presentation if you allow me to share. Do you hear me?
Yes,
Yes,
I hear you.
You can click the green
yes.
screen share button at the bottom of your screen to share your screen.
Yeah, sure. I'm just trying to. It's kind of getting a little bit slow, but it should be coming.
There you go.
Yeah, sure. Okay. Do you see
And then
the?
if you just click into the full screen presentation mode,
Yeah.
the little screen icon in the bottom right corner.
On the right.
Bottom right corner of PowerPoint, next to the slider there, the plus and minus zoom slider, the one just to the left of that.
This one? No.
I can't see your mouse, unfortunately.
Okay. Just let me. Usually when I do this, should be okay, right? Do you see it now?
No, we're seeing a black screen.
Okay.
Oh, there we go. It just
Okay.
took a moment to load.
Sorry.
You're good to go.
Okay, so I think I'm short in about 1 or 2 minutes, but I'm gonna try to make make up my time. So my activity is about applying advanced technologies for the sustainable upcycling of brewers' spent grain into value-added food ingredient. So just as you might know, I'm a research scientist based at Saint-Hyacinthe Research and Development Center in Quebec. And my research interest is around developing alternative plant proteins, particularly looking into advancing the circular economy through the valorization of agricultural protein residue and looking into their value as in terms of nutritional quality, their techno-functionality for food applications, and as well as their health benefits and bioactive properties, including allergenicity. So as all you know, brewing beer creates a byproduct that has great value. It is particularly rich in protein, fibers, and mineral. And actually, for many years, it has been wasted, just used as feed or dumped into earth. So we are really looking to actually prevent wasting such highly valuable residue and turn it into a valuable food product. So there is an opportunity, of course, there are already an interest going on in using BSG as a flour into baked products and to enrich the food products with proteins and fiber. But we are looking to go beyond that one and really prepare some value-added protein rich ingredient, as well as using some dietary fibers to prepare products like oligosaccharides and phenolates. So a summary of our projects is that we are looking to apply some of these advanced green processing technologies like microwave, ultrasound, pulse electrical field, and enzyme-assisted extraction to help enhance the yield of extractability and the yield of protein recovery from BSG, because as we all know, BSG is treated, so most of the protein gets denatured, and it gets very hard to get high recovery yield from such products. So the hypothesis is based on that these type of technologies can damage the cell, and through different phenomena like electroporation, cavitation, to improve that extraction. But also these technologies have also the possibility to impact the structure of the protein, leading into improved functionality or digestibility, thereby enhancing their nutritional properties. So we are looking to prepare different protein-enriched ingredients, including, as I said, by enzymatic assisted extraction, some of the oligosaccharide. And through this project, we will be considering different factors, like, of course, the yield, the recovery, the impact on the physical, chemical, and the structural properties, as well as the techno-functional properties, and also looking into the impact of these pre-treatment on the biofunctional properties, including allergenicity. As you know, we are more and more going to be exposed at new sources of proteins, processed sources of proteins. So it's very important to know the impact of this processing on the allergenicity of proteins. As well, we are going to look into the nutritional value by considering the digestibility and determining the protein quality scores. Through this project, we are also looking to develop eco-efficiency scores to assess the environmental impact and the energy saving of impact of using such technologies. At the end of the project, we are looking to use our developed ingredients into food application. This will be done in collaboration with our industrial partner, who is Still Good Food. Still Good Food is already very much engaged in this path, and they have already some commercial product, and they have been the winner of the Agriculture and Agri-Food Canada Waste Reduction Challenge. So we are very happy to be partner with this industrial collaborator. So our collaborator in the team, there is from our center, Dr. Fadi Ali, who is a food engineer. He has expertise in these different technologies. As well, Alawa Ashuri, who is going to be responsible for setting up all the nutritional assessment, as well as the techno-functional properties. Reza Zarifar, who is also a food engineer and assisting also in the development of the process. As well, we are collaborating with Dr. Salwa Karboun and her team from McGill University, she is going to be looking into the development of the enzyme-assisted treatment and the characterization of the BSG dietary fibers and generated oligosaccharides. So that's end my talk, and thank you for listening.
Okay, merci beaucoup, Lamia. It's very good. Thank you. At this point, we move on to activity number 7, which is the fermentation of pea protein, plant-based milk. And the principal investigator in this is Dr. Raj Verma. Raj?
Hello, everyone hear me? Yeah,
Yes.
can I have a presentation slide, please? Hello, everyone. Can I have a slide, please?
Okay.
One moment, I'm just bringing it up.
Okay, not a problem. Yeah.
Okay.
So I think so far so good. A lot of areas are there. We are exploring it in this food cluster. And a lot to learn.
Oh, there you go.
Oh, yeah.
Okay.
So my topic of the project topic is fermentation of the pea protein for developing the plant-based milk. This is to explore the fermentation tool to improve the pea protein functionality. Next slide, please. So the project will be partnered with the AFC, and Dr. Shi Wong will be our project lead, providing the support for the research. Commercialization and the plant trial will be conducted at a plant-based food manufacturer named Yoso, located in Cambridge. And Microtechnology Inc. will be providing us a fermented pea protein. Next slide, please. So as we know that plant-based beverages is growing at with high pace. And so there are several kind of the beverages are available in the market, including soya milk, oat milk, pea milk beverages. When you compare with these beverages with the bovine milk, they lack in a nutritional balance. They lack the taste. However, they have a functional active ingredient which has a health promoting effect. That is more popular. Pea protein as is one of the most popular pea protein, one of the best plant protein when we compared with the other plant protein due to its non-allergenicity. However, it has a benign taste and low solubility. That causes the main challenges for making a beverage kind of product. Can we have a next slide, please? So we will be using the fermented pea protein to basically focusing on the two aspects. That's the benign flavor, how we can make the pea protein with a clean flavor, and how we can improve the functionality of the pea protein, especially solubility for developing a pea beverage, as you can say. So we will be analyzing it at AFC and nutritional profiling it, enzyme digestibility, and physical and chemical characteristics of the pea protein, as well as fermented and non-fermented, and with the beverage also, and the product stability when we'll go to the pilot scale and as well as at the commercial scale. So this is a snapshot what I will be doing it. On October the 1st, I'll be providing more details about the project. Thank you very much, everyone, for listening to me.
Thank you, Dr. Raj. That was short and sweet here. I'm just taking a look at the time. We're doing fine. The next project on the list here is reducing HGH by improving organic waste management in produce processing. And the principal investigator in this is Dr. Alexandra Gorchik. I hope I pronounced your last name correctly.
That's close enough.
Oh, close enough? Okay, good. Thank you.
I want to say thank you to CIFST for organizing this event. It's been really a pleasure to hear about the rest of the projects, for the first time and knowing who else is involved. So I'm really excited for October 1st to see everyone in person. So for our project, we're really interested in reducing greenhouse gas emissions by diverting byproducts for the fruit and vegetable processing industry, and then to use them to manufacture new ingredients. And the reason we're interested in this space is because the fruit and vegetable processing sector generates very large, repetitive, and predictable volumes of unavoidable byproducts, such as pumice, peels, or liquid byproducts. And the consistency with which the production happens, and also the high volumes of material that originate from single sites, that offers an opportunity to reuse these materials in production of new products. And so our research is a collaboration with several industry partners. We're working with Norterra Foods, Gum Products International, and other partners as well. And the research involves several different sub-activities within the project, and each sub-activity is tackling a different byproduct stream. So one activity we're tackling this year includes the development of a clean label shelf life extender that's using onion processing byproducts like onion tops, onion tails, and skins. And the work is being done in partnership with Gum Products International, or GPI. And so GPI is a manufacturer and supplier of hydrocolloids in Ontario, and they also have a line of clean label antimicrobials. And so they're interested in potential development of new products to extend their product line with a new antimicrobial that's derived from byproducts. And so in this project, we're working with them to complete sensory testing and also microbial challenge tests in a food formulation to get a better understanding of how or what can be done to successfully create a new antimicrobial ingredient from onion byproducts. In another sub-activity, we're tackling corn juice. So this one is working with Norterra Foods, and some of you may know them better as Bonduelle. So Bonduelle, they rebranded fairly recently after the North American division was sold off to Canadian investors. And they're North America's largest vegetable processor, and they own around 90% of the frozen veg market in Canada. And one of their top products is frozen corn. And so when they're processing the corn, they remove the corn from the kernels, from the cobs, and then the cobs and husks are pressed to remove as much moisture as possible so they can sell the solids to animal feed. And so during this pressing, they generate around 15,000 tons of juice from corn cobs and husks, and that's just from the Ontario processing facilities. And so all of this juice is then discarded by irrigating it on fields. And so this juice, however, contains starch, protein, sugars, and all kinds of other potentially interesting compounds. And so we're doing this project is working together to identify and evaluate different opportunities for them to repurpose the juice, either by processing it themselves and investing in new processing lines, or by selling it to another customer as raw juice for further processing. And so during the research, they're doing some analytical work, and we're going to complement this with market assessment to help evaluate the various options and also provide recommendations on where to go next with the corn juice. And the final activity we're tackling this year is working on apple pumice to understand how apple pumice can be used as a source of enzymes that are useful for protein binding in plant-based foods. And so apple pumice is the solids that are left over when apples are pressed during juice processing. And right now, a lot of processors send their apple pumice to landfill because apples are high in sugars, they're acidic, and so those factors make them not very good as animal feed. And so as a result, a lot of processors still end up sending much of it to landfill. And so the hope is that we can instead develop high-value ingredients from apple pumice that could be a clean label and relatively simple to produce. So that's it for me for this year.
Thank you very much, Alexandra. Appreciate it. And the next project on the list here will be presented by the principal investigator, Lingyun Chen, and the title is Plant Protein Phenolic Complexation Towards Healthy Plant-Based Food Development. So Lingyun, please.
Okay, my pleasure to present our work here. This project also addressed food sustainability by developing plant-based food. We are going to focus on two major chemical components in plant food sources, including plant protein and phenolic compounds. We try to see how those interactions can be modulated to develop healthy food. We have a team from 3 institutes, including myself from University of Alberta, with expertise on plant protein. Our collaborator, Dr. Trasta Veta from University of Manitoba, with expertise on phenolic compounds. She's here also online. We also have a collaborator, Dr. Lovemore Malonger from AFC. His expertise focuses on processing of agricultural byproducts. We know that plant protein and phenolic compounds, they are separated in different crop tissues. However, once you get processing started, like milling, you destroy the structures, and then protein and the phenolic compounds start to interact with each other. Those will include covalent interactions and non-covalent interactions. With further processing, like heating, pressure, pH change, those interactions would become more intensive. And those interactions are important to determine the food quality, like flavor, taste, protein digestibility, or health benefit of the food. So if we talk about plant-based food, we cannot avoid those interactions. On the other hand, in previous research, we have some impression that those interactions may lead to negative impact. For example, protein binding of dunning, that will maybe make protein taste bitter, and also this may decrease the digestibility of the protein. However, more recent research demonstrates this really depends on the protein structure, phenolic compound structure, and the processing conditions. If we have the protein binding of small molecular phenolic compounds instead of tanning as a large molecular phenolic compounds, protein digestibility may not be decreased. On the other hand, this binding may allow plant protein-based food as a matrix to encapsulate the phenolic compounds to sustainably release them in the gut. That will allow them to have better antioxidant capacity, anti-inflammation capacity. This is important to address the low bioavailability of many of the phenolic compounds. They are existing in food. However, when you eat them, they will quickly released from the human being, and then bioavailability would be quite low. So if we have those combination, maybe plant protein will control the release phenolic compounds to enhance their health benefit. So in this project, actually we aim to investigate interaction between plant protein and the phenolic compounds in relation to the functional properties and the digestibility of plant protein, as well as the stability, bioaccessibility, and bioactivity of phenolic compounds. We will specifically focus on pars and cereal proteins, as well as phenolic compounds from agricultural byproducts like grape pomace, or from the hearts of cereals. We have 2 industry partners, including Roquette and Crush Dynamics. Roquette is an important industry player in plant protein processing. Crush Dynamics works on phenolic compounds from grape pomace. So hopefully with working with this industry, we can add value to phenolic compounds from agricultural byproducts. Thus will reduce food waste and strengthen the value-added chain. And we also hope to collaborate with these 2 companies to develop some plant protein-based food that can be healthy to address some of the chronic disease like diabetes, cancers, cardiovascular disease by delivering those phenolic compounds. This will improve public health and wellness and increase the sustainability of our food systems. So I will stop here and give more details in the meeting in October.
Very good. I appreciate that. Save some for the October 1st meeting. Yes. At this point, we'll have to call back Dr. Michael Gansel again. Another project he's working on has to do with the novel sanitation technologies for improved food quality and safety. So I'll pass it back to Michael again.
Yes, I want to briefly introduce the project. The common denominator with the first project is that we are characterizing bacterial communities. The difference in the first project, we aim to use the communities for as useful fermentation microbes. Here, we want to disrupt microbial communities that reside in a meat processing plant. It has become increasingly clear in the last 4 years, and that's documented in a dozen papers or so for Listeria monocytogenes, that contamination of ready-to-eat meats with Listeria occurs from bacteria that permanently reside in processing facilities. And we have worked with an Alberta meat processor to document that meat processing facilities specifically, but likely generally food processing facilities, they are ecosystems that provide food and shelter for stable communities of microbes. And we documented that some of the microbes from meat at the end of the shelf life of vacuum packaged primal cuts originate from a floor drain in the facility, and other microbes originated from the packaging machine that was sampled after sanitation. And the 2 sampling times documented that the microbes we selected identified 6 months later were identical to the ones that we identified 6 months prior. So what we want to achieve in the current project, together with my collaborator, Rupesh, a food safety engineer, is first, we want to document how microbes move through the facility from floor drains to conveyor belts to meat. And the second, we want to evaluate novel sanitation technologies, and these include nanobubbles that contain either ozone, and that's a commercial unit that we use in collaboration with a US supplier. And second, can we also pack the nanobubbles with cold plasma to disrupt transmission of bacteria to food, and thus to extend the shelf life, to improve safety, and to reduce food waste. And I will start with one interesting piece. The meat processor had a fire in the facility this spring. So they temporarily suspended operations, but that also means we will have the opportunity to sample a brand new facility to document how the new facility starts being colonized by bacteria, and we'll see what we get. So yeah, thank you.
Michael, that was very creative, making lemon juice out of lemon. Very nice. Okay, and thank you all for still being part of the in this chat room. So we just have one last activity to discuss here, and this will be presented again by Dr. Raj Verma in the theme of fermentation again. This time is fermentation of mushroom waste to produce umami extract. Dr. Raj.
Hello, everyone. Can I have a slide, please? Can I have a slide, please? Hello?
Yes, one moment.
Yeah, thank you. Yeah.
I don't know if I received the second one, actually.
Oh, I think there are 2 presentation was there. Okay. In the same email, there's 2 presentation was there.
Oh, yes, sorry. I missed
Okay.
the second one. I'm loading it now.
Yep.
Apologies.
Okay, while we're waiting for the loading, and I really want to thank Dr. Tony Savad, Dr. Dan Ramdat for taking time out to be part of this very, very important initiative taken by CIFST and in this inaugural first round of the cluster. Anyway, back to the presentation here.
Okay, so hello everyone. The project title is Fermentation of the Mushroom Waste to Produce a Umami Extract. This is this time we'll be using the fermentation as a tool to create a umami extract. And can I have a next slide, please? So the project will be partnered with the AFC and Guelph, and Dr. Shi Wong will be the project lead. She will be providing a research support to this project. And plant-based food manufacturer, USO, will be conducting all kind of commercialization and pilot plant trial. And once the extract is developed, it will be tested at Hongsheng restaurant to develop the different kind of sauces and in the food application. Last but not least, the mushroom grower in Ontario, we are already working with them. So next slide, please. So as we know that mushroom consumption across the globe is continuously on rise. So is Canada. Due to it has a high protein, it has an essential amino acid, it has a low fat, and it has a high fiber, nutritional fiber. Also, it contains the high vitamin D and phosphorus. As the consumption of the mushroom is growing, there are challenges there at the farm level that the waste is getting generated, not at the farm level, also at the store level, which it's approximately, we have calculated around like 12 to 15% waste is generated. And that is a good opportunity. Can I have a next slide, please? So as you can see in this slide, the first one is a mushroom log there. Once the mushroom is cut, and there's a log, you can find a lot of mushroom pieces are still left out, which is roughly around 10 to 15%. And that create a opportunity for us to develop a umami waste using the fermentation technology. Can I have a next slide, please? So through the fermentation, we can use we can use a nutrient from the mushroom with different kind of the flavoring compound, and we can replace the monosodium glutamate, which is considered as a unhealthy ingredient, which is used as a flavor enhancer. And some people may have a sensitivity for asthmatic and headache also. So the whole project is goes around how to take a farm waste and even the store waste and develop in a value-added ingredient, which not only is good for the sustainability, it's also creating a novel ingredient for the plant-based industry. Again, I would like to thank CIFST and AFC for obstructing this project and working this project to explore the fermentation to develop a novel ingredient for the Canadian and for the world market. Thank you everyone for listening to me.
Thank you all. As you can see, the collaboration agreement was signed this year in March 2024. That did not give researchers a lot of time to really get moving on their project. So we're thrilled that these researchers, first class and very innovative in terms of moving the project forward here. So it's already, we're getting close to September. In the next little while, I'll be visiting most of these researchers just to follow up in terms of what they said that they're going to do, and to do a site visit with some of them. I've done some with a few of these researchers already, and I'm very, very impressed, and I'm very enthused in terms of the commitment they have in terms of working on this project. This is the inaugural first round of the cluster here, the food cluster for CIFST, and hopefully on October the 1st, we're able to share a little bit more in terms of what the second round will look like. And also we'll discuss on October 1st in terms of the process where industry can get involved with researchers in terms of submitting a proposal to the cluster. We like this, we believe this is a huge opportunity for CIFST, AFC, and the collaboration that we have together again. Again, I don't want to belabor this point, but thank you very much to Dr. Tony Savard, Dr. Dan Ramdath. Unfortunately, we are not entertaining questions today. However, let's save all those questions for October the 1st, and all the details and questions that you have, we can discuss that. In fact, we'll have a sort of roundtable discussion where you can you as the audience can pose some of these questions, and the researchers or some of the expert folks there will answer some of the question. So it's 12:59. I like to be on time. So thank you very much, and hope to see you again on October the 1st. Thank you very much, all. I have to say goodbye now. Bye-bye.
Thank you. Bye-bye, everyone.
Goodbye.